was a graduate student. I got just a short story, mostly for the students. When I was a grad student, I came to Ames as an internship. Ames and NASA in general has a lot of intern programs and encourage students to apply to them. I was a student. When I came there was a real senior guy who was doing biology in Antarctica, and he needed somebody who could do some instrumentation and mathematical modeling. And I said I could do it. I knew, knowing that I could learn it between then and when I needed to produce results. And so I've been working in Antarctica since I was a student. And just last week, somebody died, a scientist died, driving a skidoo across the ice and into a crevasse.
Yes.
Right? Some of you may have seen that on news. And that's a tragedy. But the attitude toward risk in Antarctica is so different than in space. Nobody is saying, let's stop the Antarctic program because somebody died. People aren't saying, let's be cavalier about safety either. It's extremely rigorous, the training and the safety. But there's an appreciation that if you're doing anything worth doing, all the way down from crossing the street and driving on 101 to exploring Antarctica and going to Mars, there's some risk involved. I read the other day about somebody driving down the road on 101, and the opposite lane, a government truck, I forgot what it was, a PG&E or something, lost the cap that crossed the lane, came through his windshield, and dead right away. I'm not going to stop driving 101. Actually, I take 280 whenever I can. So yeah, I am going to stop driving 101. But the risks are somehow just part of what you have to accept. And somehow in space, we have the attitude that risks are not accepted. That if spacecraft blows up, or the equivalent of somebody falling in a crevasse, then we have to ask existential questions. Are we really going to, should we really be doing this? Should we really be exploring? I think that's a recipe for doing nothing but staying home and playing video games. And that's just, I think that's very unwise. I think that holds back the space program. So I've been pushing for not a cavalier attitude towards safety, but an attitude that's more realizing that when people go to Mars, they're going to do things like fall into crevasses, and there's going to be people that are going to get killed, and we've got to plan around that and work around it and come to grips with that and realize that there are great things to do and great things to take risk. It's a great
When you think about getting back to sort of the macro story, terraforming, planetary engineering, shake and bake planets, or whatever you want to call it, I think it was you that I remember talking to about, is there a go, no go if we find some signature of life? Is there an ethical point of no return there? What is that?
Yeah, I think the exploration of Mars poses two completely new questions in environmental ethics. The first question is life better than no life? So on Earth, a way to say it is life better than nature? Which do we value more, life or nature? On Earth, life and nature are the same thing. People say nature, respect nature, or people will say respect life, and it has the same, it's the same. Once you go away from Earth, though, nature is no longer equal to life. So you could say the rings of Saturn are a natural feature and we should respect them. But it's got nothing to do with life, it's just got to do with the beauty of the rings of Saturn. So that same question applies to Mars, and it's something we have no experience on Earth, separating nature from life. The second question, which is more germane to your point, that is raised by Mars exploration, that's a new question in environmental ethics, is how do we treat an alien life form, really alien? What we hope to find, what I hope to find on Mars, is life that's not related to life on Earth. As you all know from Biology 101, or maybe it's 301, all life on Earth has the same biochemistry and genetics. There's only one type of life on Earth. Right? It's, as they said in the Star Trek, life as we know it. If we go to Mars and we find life that's not related to us, how do we interact with that? What do we do to that? How do we treat it?
I agree.
And there's basically been three suggestions. One is go, put it in a can, bring it back, and study it. Because it's certainly going to be microscopic, which means it'll fit in a very small can. Right? You can put it in your lab and study it. Sort of like what we're doing with smallpox. We've eradicated it in the wild, we studied it in the lab. We will learn a lot from it with no risk to being hurt by it. That's one approach, and really a lot of people suggest it. The other approach is don't do anything. Quarantine Mars, leave it alone, sort of hands off, don't interfere with the natural course of events. Leave it alone. And I reject both of those. I think our approach ought to be helping. Sort of, we're from the government, we're here to help. Whether you want it or not. Not so much whether you want it or not, but why would I make that case? Because if you look at Mars, if there's life there, I would argue that it's not doing well. And it's probably on the edge of extinction. Because if it was doing well, it would have covered the whole planet like it does on Earth. When life does well, it takes over. It leaves no corner uncolonized, as we see on Earth. And to be more technical, when life is doing well, it's in charge of the cycling of the elements that are important to it. On Earth, carbon, nitrogen, phosphorus, those are all dominated by biological systems. Biology is in control. You can see that from the Earth, from the other side of the solar system. On Mars, that's not happening. So if there is life on Mars, it's not doing well on this global homeostatic sense. And so what I would advocate is we figure out what it needs to do well, and we change the planet to enhance the diversity and richness of that life. And people say, well, isn't that interfering? Yeah, it's interfering. But I say, by analogy, if you're walking down the sidewalk and somebody falls over with a heart attack, are you going to go and try to do CPR? I will. I would. That's interfering with the natural course of things. Similarly, if I see a stone rolling down a hill and it's about to hit a cat or something, or a child, I'll try to deflect it if I can, right? That's interfering, but I think that is the responsibility and the prerogative that we have as intelligent creatures, rational creatures who can see the outcome and can make choices and decisions. We can't forfeit that birthright. We can't say, the universe has a do not touch sign on it, we're not allowed to change anything, and we're not smart enough to even try. I think that's the wrong approach. So that's a long-winded answer to your question about what we do if we find life. I think we should try to enhance its richness and diversity, and that should be our approach, in my view, as we move out beyond the Earth in general. We ought to pro-life. I'm pro-life. I hear that's a very popular stance. I also hear on the news, so-and-so is pro-life. So-and-so pro-life. Me too.
What about, one of the things that's intrigued me is about the nature of Mars itself and dealing with it. I mean, again, it was probably you in the book, when we got into this discovery of perchlorates on Mars. Pretty interesting. I mean, that's a relatively recent discovery, and the implications of that would look to me like fairly significant, because you got this toxic carpet on Mars that's harmful to humans, but yet may be okay for life, or how does that work?
Well, maybe a little background is useful here. On Earth, virtually all environments you go, there's salt present at some level. The oceans got salt, and the deserts have salt. There's salt just about everywhere. In your backyard, there's some trace levels of salt. And that salt, virtually everywhere on Earth, well, not literally everywhere, but virtually everywhere on Earth, is sodium chloride. And so we actually use the word salt to refer to sodium chloride, even though scientifically salt is a much broader list of compounds. So we knew that there was chlorine on Mars, and we knew that there was sodium on Mars. We had measured the presence of those atoms, but we didn't know their molecular form. And we assumed that it was sodium chloride, just like Earth, everywhere on Earth. On Mars as it is on Earth, right? So we assumed that it was sodium chloride. Well, in the Phoenix mission, which was the previous lander for Curiosity, 2007, did have an electrode that was designed to search for nitrate, and the signal just went all the way through the roof. What the heck could that be? The only explanation was that what was in the soil was not sodium chloride, but a form of sodium chloride called perchlorates. where the chlorine atom, for those of you that have studied chemistry, where the chlorine atom is attached to 4 oxygen atoms, not just directly attached to the cation. So that was really bizarre, completely unexpected. You may, if you have encountered perchlorate, it's because you do model rockets. Perchlorate is what you stuff into a model rocket as solid rocket fuel, and then you light it, and it shoots off. And you get a t-shirt, I love the smell of perchlorate anymore. Because it's solid rocket fuel. It's stable at room temperature, but when it heats up, it decomposes explosively. And there's microorganisms that can eat it, but for humans, it interferes with the thyroid. It places iodine, that's it, yeah. It displaces iodine, and so it causes thyroid. So control in the state of California, the level that's allowed is a few ppb. So if Mars soil was in your backyard in California, your yard would be a Superfund site. So that's going to have problems when people go. And as far as we know, it's everywhere on Mars, at a few weight % in the soil. So that means you can't track the dirt into the habitat, you can't get it in the water, you can't grow plants in it because the plants will uptake the perchlorate and then it'll be in the food.
You got to work around perchlorate.
We got to work around perchlorate. And what I say people is that that was a big surprise. No one had expected it. We were all sure we knew the answer. This is actually a little side why I love planetary science, because there's many times where all of us, all the scientists that do planetary science are sure we know the answer, and we go out and it's wrong. And perchlorate on Mars is one example. Oceans on Titan is another. I could do more if I thought about it. But so we were wrong. We were completely surprised. What I say is that I would be surprised if that's the last surprise we get from Mars.
What would it be? I mean, we're going to turn it to questions and answers.
Yeah, great.
What's the last thing? Just that right at that point. Okay, what you probably already know. You're prepared for surprise. Where is it going to come from? How is it going to happen?
If I knew it, wouldn't be a surprise. You know, it'll be a surprise. That's the problem with surprises. You don't know where they come from. Who's that sage of the political establishment? You know, unknown knowns, known unknowns, and unknown unknowns. These surprises by definition are the unknown unknown.
Yeah.
There was actually a German truth to that statement. The only thing Rumsfeld said.
But you're a big person for drilling. You got to get down below that surface.
We got it right.
The chloride surface. Okay, that's one thing.
Chloride may be depth too.
Yeah, depth. How deep is that?
We don't know. We've only drilled on Mars about this deep, so we don't really know what's going on under the surface. But that's got to be the most interesting place, because the surface is just dead. Yeah. Dead as a doornail. I don't know why doornails are so dead, but they are very dead. You can look in here and find Christmas Carol, where Marley is dead as a doornail. That's the best use of it. But the surface of Mars is dead as a doornail. So if we're going to search for life, if we're going to search for water, if we're going to search for anything interesting, we have to learn how to drill down. But drilling is really hard. On Earth, it's easy because you can hire human beings with hands to operate the drill. On Mars, it's just so difficult that the next rover won't even have a drill, even a little one, because NASA had so much trouble with the little drill on Curiosity. So much trouble that they just said, we're not going to do drilling.
Humans as drillers.
That's their main. When people tell me we're going to send humans to Mars, what do you want them to do? From a science point of view, the main science task I would give them is drilling. Although I don't think science, I take issue with the view that science is why we're going to Mars. Even though I'm a scientist, and it's this heresy to be saying it. If any of you are in the science division at NASA headquarters, don't quote me. But you know, the gospel at NASA is that the purpose of going into space is to do science. But I think that's completely wrong. I think the purpose of doing science is to learn how we go into space, and if we want to go into space. So we explore Mars to decide, is this somewhere we want to go? We don't go to Mars to learn science in some intrinsic sense. Science is not a goal, it's a tool. it's a way of achieving other goals. The only goal that I can see that's intrinsic is human equality and richness of human life. So science must be perceived as a tool for enriching the quality of human life. So why are we doing science on Mars? To ask the question and answer it, hopefully. Is this a place which will enrich the quality of human life? Is it a place we want to go? Is it a place we want to do the things that humans do? And can we go there, and can we do it? But often the conversation is forced to be channeled into what's the science that will be done. So if humans go, what science can they do? NASA and the Academy put out this study, Science Enabled by Human Presence. Okay, well, if you want to ask that question, then the answer is drill. But I think it's the wrong question. That's just the heritage in these. Thank you for